All right, AP Stats, last page, number 15. A lot going on with this problem. So a university study, they were looking at babies crawling, and they looked at the average temperature when they were 6 months. So we can even say here at 6 months. So basically when the babies were half a year old, and they want to see if there's an association between the temperature and at what age did they crawl. So over here we have like the crawling age. So let me just give you like this dot, for example. This dot, we'll say about 48 degrees maybe. So maybe it was about 48 degrees at 6 months. And this baby had a crawling time at 33 and a half weeks, about 33 and a half weeks. So it was about 48 degrees at 6 months for that baby, and the crawling time was at 33 and a half weeks. So part A says to draw the line of best fit on the graph and mention to pick 2 points. So what you should do is pick 2 points and really pick 2 x points. It's like if I picked x equals 30 and then I picked x equals 70, and I plug them both into the equation, we should get a corresponding y value. So if I plugged in 30 for x, plugged in 70 for y, get 33.6, and I would get 30.4. So then I could just graph these, and I know it's not going to be perfect, but it gives us at least an idea. 33.6 would be like right there. 70 would be 30.4, maybe like right there. And then I can just connect these 2 dots, and here is my line of best fit. So pick 2 points, plug them in, and then this is your regression model. All right, part B says describe the association in context. Okay, well, describing this linear association, we can say in context. The association, mention what the context is between the temperature and crawling age is, so we have context down. Now, what shape do we have? Right, this looks somewhat linear. What's the direction of it? Negative. And then how strong would you say this is? I would say moderate in strength. So remember, shape, direction, form. Or form, direction, and strength, sorry. We could also mention possible outliers. We can say that it looks just from this data set that maybe this guy might be a possible outlier. So there's a possible outlier at about 52, and they didn't tell us I'm assuming this is degrees Fahrenheit. At 52 degrees Fahrenheit with a crawling age of about 29 weeks. All right, I'm kind of shorten this up a little bit. All right, so again, describing the form, direction, strength, and then any possible outliers. All right, these next 4 are also pretty important. So explain in context what the slope means. So looking at our equation up top over here, we have the slope as negative 0.08 over 1. Now, in context, what does this mean? Very important that we say according to the model. And remember that the slope is calculated by a change in y over change in x. So x in this case is for every 1 temperature, or every 1 degree. So for every 1 degree, the y value decreases by 0.08. So that is the average crawling age. So we can say the crawling age. Oops, messed up, because it's not the crawling age. We need to mention that it's the predicted crawling age. Decreases by 0.08. We're talking about weeks. Okay, so according to the model, for every 1 degree, the predicted crawling age decreases by 0.08 weeks. All right, explain in context, what does the y-intercept mean? Well, the y-intercept over here was at 36. So remember what a y-intercept is? It's a point, 0, 36. And y-intercept, to be honest, is pretty strange when it comes to linear regression. Sometimes it doesn't even make sense. Like for something like this, it would be like, according to the model, a baby that had an average temperature at 6 months of 0 degrees. Remember, this is outside, not the actual baby. At 6 months having 0 degrees, we can say would have a predicted crawling age of 36. Weeks. All right, jumping to the next one. R squared, remember this is just that sentence. Did they give us R in this case? I hope they did. Yes, they gave us R is negative 0.70. And so R squared, if I take this value and just square it, 0.49 or 49%. So we can say 49% of the variance in y, remember y is crawling age. This is just that cookie cutter formula, cookie cutter statement. The variance in y can be explained by the variance in x, which is temperature. That is the only thing that you can write down with R squared. And then for letter F, in context, what does a negative residual mean? So I'm just going to draw a negative residual. So remember, a negative residual is when there's a point that's actually below the regression model. So what does that mean? Well, in this case, it would mean that the y value, the actual y value, is lower than what the model estimated. So over here we have a y hat. This is a y hat. And that value, that predicted value, is higher than what actually happened. And this is what a negative residual means. And y valued is we're talking about crawling age. So a negative residual this would mean that the actual, and the y's are talking about crawling age, the actual crawling age of the baby, or of a baby, is lower than what was expected. Or we can say that the model, or the equation, the model overestimated.